Our systems are designed and built for the paper and pulp industry by people who understand the challenges involved. As our customer, this means you can rest assured that our solutions suit your individual needs and meet your company's goals in terms of productivity and quality. Paper quality is determined by several factors, including density and wrinkling. Problems in these areas are common in the paper industry. Uneven density and wrinkling of paper reels occurs if there is inadequate control over the positions and forces that control critical stages of the winding process, i.e., winding and spool transfer from the primary arm to the secondary arm. Because paper is sold by the ton, not by the foot, the density is obviously extremely important. Wrinkling causes big problems in newspaper manufacture, as paper breaks lead to stoppage of the printing presses. One typical problem on machines without an ROS system occurs when the nip force is controlled by measuring the pressures in the cylinders. Because the cylinders are mounted some distance away from the spool, where the nip force is actually generated, the friction that arises in the machine reduces the accuracy of the measurement results. As the mechanical components and cylinders become worn, this problem grows and the inaccuracy of measurements increases. If, as in this example, you do not have force control on both sides and do not have control over the prevailing conditions for each reel either, the nip forces will lack repeatability. This increases the risk of varying density and wrinkle formation, both when changing reels and during winding, where paper breaks may also occur. When lowering the spool from the primary arm to the secondary arm, changes may occur in the lowering speed, and misalignment between the reels may also result in varying density, wrinkles, and paper breaks. Our solution is based on mounting load cells directly at the point of force application, as well as on the position sensors in each cylinder. The load cells are therefore installed in the primary arm and secondary arm and in the spool clamp. This allows us to measure values in real time, which means that we know the actual forces in the critical transfer from the primary to the secondary arm. Acceleration, speed, and force can then be adjusted by positioning cylinders that are controlled by means of custom software. Control through online measurement and adjustment. ROS provides control on both sides of the machine. The system controls the nip forces and corrects for the change in angle that occurs as the reel is lowered. Alignment, acceleration, and speed are also controlled during lowering, which minimizes any variations in web tension. During reel changes, the forces in the primary and secondary arms are balanced to ensure that the desired nip force is maintained. Another important parameter is the density, which is also measured by the system. A correct measured value is attained after just 650 feet. With ROS, all values are documented, which makes it easy to generate nip force graphs and set the machine up for different grades of paper, as well as improving the repeatability of the winding process. ROS means better performance. ROS therefore enables you to control the process so that it produces reels of the right density with wrinkle-free paper and reduced risk of paper breaks. A typical example is a mill where 3 to 4% of the jumbo roll is normally rejected due to wrinkling. With ROS installed, the waste was reduced to less than 0.5%. This reduction meant a saving of around $130,000 per month for the paper manufacturer. Because of the amount saved, the payback time on the investment is around 3 to 6 months. The improvement in paper quality resulting from this investment naturally also means more satisfied customers and hence increased sales. In other words, our solution is your assurance of quality.